Welcome to This Explainer. Today, we're diving straight into the intense, highly dangerous world of navigating massive merchant ships through ice-filled waters. And look, this isn't just about steering a boat. It's really about anticipating nature's most crushing physical forces and relying on a mix of high-end technology and raw human instinct just to make it through in one piece. Put yourself on the bridge of a massive cargo vessel for a second. You're heading into freezing waters, you've got thousands of tons of steel and precious cargo right under your feet, and the ocean ahead is quite literally turning solid. So, how do you actually survive that without catastrophic structural failure? How do you negotiate this frozen battlefield where just one single wrong move can leave you hopelessly trapped, or worse, completely tear open the hull? Well, we're going to unpack the exact protocols that turn a standard maritime voyage into a high-stakes tactical mission against nature. We'll break down the concrete steps, the detection methods, and those split-second decisions that are absolutely crucial to conquering the ice. Chapter 1: The Frozen Threat and Vital Intelligence. Okay, before we even see a single chunk of ice, preparation starts hundreds of miles away. You absolutely cannot just sail into an ice field blind. And that's where the NAIS comes into play. The North American Ice Service acts as our primary intelligence hub, mostly operating from February through June. They're out there collecting vital data to warn shipping about the sheer amount and extent of icebergs and sea ice, especially around the notoriously dangerous Grand Banks. They broadcast daily reports and charts via VHF and Navtex to keep mariners alive. I mean, without this constant data loop, these ships would literally be navigating in the dark. So, imagine you're approaching the danger zone. This checklist is essentially your final go, no-go strategic gate before committing the ship to the ice. You have to ask yourself, do we have the latest intelligence on ice concentration? Is our vessel's ice class actually up to the task? Are the engines and steering gear fully reliable for a quick response? Now, obviously, if there is an alternate route available, you take it. But if you have absolutely no choice but to proceed, you have to rigorously assess the physical state of your ship first. And the absolute biggest danger here? A lightly ballasted ship. Think about it. If a vessel is riding high on the water without cargo, its propeller tips are fully exposed to lethal ice strikes right near the surface. Striking heavy ice in that state practically guarantees mechanical failure. So, to survive, a ship has to be ballasted as deeply as possible. You fill all those ballast tanks to ensure the propeller and the rudder are completely submerged and safely shielded beneath that surface ice layer. Chapter 2: The Detection Dilemma. All right, so we're deeply ballasted and moving into the theater of operations. But finding our frozen enemy is far harder than you might think. It's time to completely shatter the illusion that our advanced ship radar is going to keep us perfectly safe. Sure, massive icebergs, those can usually be picked up 4 to 15 miles away in good conditions. But sea ice, radar might give you less than 6 miles of warning. The reality is, ice just isn't a good reflector of radar signals. But what's truly terrifying is the threat of the growler. Because these detached pieces of ice have been eroded by the water, they have this incredibly smooth surface that actively deflects radar signals away. Throw in some rough weather where sea clutter messes with the radar for a mile or so, and these threats become virtually invisible to your tech. They turn into lethal hazards, hiding just a couple of miles off your bow. Relying completely on radar in these conditions is a fatal mistake. So, because the radar fails us, human vigilance has to take over. You rely on nature's warning signs. One of the most reliable first indicators is called ice blink. It's this luminous whitish reflection on the underside of the clouds ahead, and you can see it long before the ice itself even crests the horizon. Watch officers also have to look out for thick bands of fog directly over the ice edge, or even the sudden appearance of wildlife, like birds, way further out to sea than you'd normally expect. Chapter 3: Tactical Ice Entry. Okay, you've spotted the ice field and there are no alternative routes. It is time to manually drive a massive steel hull into an ocean of solid ice. This requires absolute precision and discipline, and the entry sequence is incredibly specific. Step 1. You must strike the ice edge at a strict 90-degree angle. This is so the heavily reinforced bow takes the impact cleanly. Step 2, you make that initial contact at a very low speed, minimum RPM, to absorb the physical blow and protect the hole's integrity. And then, step 3, once you're inside the pack, the game changes completely. You have to immediately throttle up and increase speed just to maintain headway and keep your steering control.
Chapter 4, The Navigation Paradox.
Once you're inside the pack, the master of the ship faces an agonizing balancing act, which we call the navigation paradox. Navigating through ice is not some steady, relaxed cruise. It's a constant shifting equation of speed and momentum. If you go too slow, the ship loses momentum and becomes hopelessly trapped or beset. But go too fast, those high-speed collisions risk completely crushing the hull or shearing the propellers right off. So the master has to constantly adjust the speed within this incredibly narrow safe zone, basing every move on the ice hardness, thickness, and visibility. Now, the ultimate rule of the ice is pretty straightforward. Go around the large flows, not through them. The source material actually points out that inexperienced navigators often have this, and I quote, inexplicable suicidal tendency to try and force the ship right through large pieces of ice at full speed. It's just a massive error in judgment. The goal is always to negotiate the ice, steering completely opposite courses if necessary to find open water leads. Doing that ultimately saves fuel and, more importantly, protects the ship.
Chapter 5, Emergency Survival Maneuvers. But what happens when the ice wins, the paradox fails, and the ship grinds to a dead halt? Well, if you become beset, meaning completely trapped by the ice, your immediate lifeline is to send for an icebreaker. But while you wait, the crew isn't just sitting there helpless. A vessel can actually attempt to free herself by rapidly transferring internal ballast. By aggressively shifting tons and tons of water between tanks, the crew can artificially change the ship's trim or list. They are effectively rocking this massive steel hull physically free from the ice's grip.
Now, if you are stopped and you need to reverse out, that is highly dangerous. You can't just throw the engine into reverse. First, you absolutely must keep the rudder strictly amidships. If it's turned even slightly, the ice will snap it right off. Then, you actually keep the engine turning slowly ahead first. Why? Because you have to let the forward propeller wash physically blast the chunks of ice away from your vulnerable stern. Only once that area behind you is physically cleared out can you safely begin to move astern. All of this leaves us with a pretty profound final thought for this explainer. We've just seen the radar blind spots, the sheer limitations of steel against solid ice, and the complex, delicate maneuvers required just to survive. So, no matter how incredibly advanced our maritime technology becomes, nature's frozen threats still demand human vigilance, respect, and raw tactical skill. When those radar screens show absolutely nothing but static sea clutter, it is still going to be the watchful eyes of the crew, searching for that faint reflection of an ice blink that will ultimately keep the ship from sinking into the abyss.